Ladies and gentlemen, my name is Minh Kang. I'm a physics undergrad student at University Malaya. So there's a reason why I want to talk about this topic, Milky Way, because I'm doing my project in astronomy. Before this, here is how you guys gonna ask questions, right? There are two ways you can ask questions. The first one is you can voice out, you can unmute yourself after my speech. Right? After my speech, you can voice out and ask questions. If you are too eager to ask questions during my speech, during my presentations, you can always do in the chat room. Okay, the chat box, I'm always monitoring the chat room. The chat is right beside me. Okay. I hope you guys are ready for the extremely excited astronomy journey. Let me go back to the title. The story of our home, Milky Way. This photo is actually taken, the background photo is actually taken by a local astrophotographer, Chin Kok Chung, in Sabah. Right, we can see Milky Way in Sabah. Every time I see this photo, I feel a bit emotional because not just Milky Way, that's normal, but there's a lady pointing at the Milky Way. It means something. Right, could be mean like we're really small. So I feel like I have mixed feeling every time I see this photo. It's kind of emotional. Sometimes I want to cry just because of seeing this. Right, let's go. First of all, as you guys asked, like what Milky Way? Actually, I want to ask why Milky Way? Why Milky Way is named as Milky Way? Why not the other name? So the story starts from this. Hey, a little bit creepy and scary things you see in the sky. If you had the chance to go rural area, not in KL, you will see something like this. That's Milky Way. So the ancient people relates this to, yes, Iktifa got milk. It looks like a milk, right? It looks like someone pouring milk throughout the sky from the top to the bottom. That's where the name Milky Way comes in. Milk, milky, along the way, Milky Way. So not only Milky Way, actually Milky Way is just one of the many millions of galaxies that we have observed throughout the century, right? There are like a lot of different shapes and different kinds of galaxies that we observe using state-of-the-art telescope. And like now I'll give you some of the examples. We have one of this, kind of boring, right? This is kind of interesting, it's colorful. This is kind of creepy. It doesn't look like a galaxy at all. It looks like something being spread. This looks like a Mexican head, a Mexican head type galaxy. And more creepy one, it's a galaxy as well, but it's a different kind of galaxy. All right. So next, I would like to talk about, now we have observed so many galaxies, different shapes and different kinds. A natural question that you want to ask is, what does the Milky Way look like? By the way, why Pluto is not a planet? I'm not going to answer this right now because we're focusing on the galaxy. Pluto is not a galaxy, right? So this is a natural question. How do we know the shape, the size of the Milky Way? It's challenging because we're actually sitting in the galaxy itself. It's like you are sitting in a room, perhaps doing Toastmaster virtual meeting, but at the same time, you wanna know, you wanna identify the shape of your house from the outside. So you might do a lot of guessing. Oh, my room is, the surrounding of my room is kind of square, so I will assume my house will be square as well. But in reality, that might not be the case, right? So how do we determine the shape of our home, the galaxy, the Milky Way? So we started getting clue, astronomers started getting clue from the other galaxies, all the billions of galaxies that we observe, right? So having seen the different types of scary Mexican head galaxies, generally the astronomers classify into two types of galaxies. Spiral galaxies that you see on the left, elliptical galaxy that you see on the right. Now I want all of you to type 1 if you think Milky Way looks like a spiral galaxy. or type 2 if you think that it looks like an elliptical galaxy. All right, everyone, type 1. So let's focus on the spiral galaxy since you guys are interested in spiral galaxy. I know elliptical galaxy looks kind of boring. Just look at the picture. Spiral, more beautiful, right? So in fact, spiral galaxy is kind of special. Not only that it's a galaxy, but it has got some different structures in it. It has got a bulge, right? A very bright center in the middle. We call it as bulge, galaxy bulge. And look at that. We have arms spread across the galaxy. We call it as the spiral arms. Spiral arms in a spiral galaxy. So could our galaxy be the spiral galaxy? Does it look like a spiral galaxy, elliptical galaxy, or none of the above? Right? Let's try to find out. So first of all, the first clue that we have is this. The Milky Way from our perspective. Now, if you see closely, you may see something different. Right? Not only that it looks like the milk pouring down, but it has some shape into it. Look at this. Isn't it look like a bulge at the center? And the center is extremely bright compared to the other places. So there might be a spiral structures, right? A bulge. Where is this? I believe this is in Chile because if I recognize this telescope is in Chile, right? So a bulge that we've seen from our point of view. So our Milky Way could be a spiral galaxy, but that's not enough. Okay, I'm not satisfied with just using this to identify to make sure that the galaxy is a spiral. Although we found a center bulge. So astronomer has a very amazing and ambitious way. They want to map the galaxies. Just like we map the world by exploring the continents, they want to map the galaxies by not going out from the Milky Way. First of all, we have again the bulge that we observe. So let's put the bulge at the right. Right, first clue. Second clue. Look at this. Now, astronomers have very special ways and quite accurate ways to identify the distance of stars from us. So by mapping we have like billions of stars. By mapping the distance of each star and the positions, we can do this. Now, all the red dots that you see are actually the positions of the stars and the map is related to us, right? And using the theories and all the observations we have for spiral galaxies, our astronomers are able to recover the photo back. And our Milky Way looks like this. So for those who type 1 just now, you're correct. Our Milky Way, it's a spiral galaxy, but with a lot of arms. Instead of 2 arms, it has 4 arms. So where do we situate it in our Milky Way? Again, using the distance, we can kind of approximate it, and we are actually at here, right in the middle, not too near to the bulge and not too far from the edge, right? Okay, now we have understood the galaxy and our home, the Milky Way, as an overall. Let's talk about the history of Milky Way. We're interested about how the house is built and when and why. So with this, I would like to show you, Big Bang, interesting. Big Bang is the birth of the universe, but how about the Milky Way, right? So I'd like to show you a video. It's a simulations, incredible simulations from a supercomputer showing a Milky Way-like galaxy. We couldn't simulate Milky Way because it's within ourselves, but we can do similar thing. So as you can see, I want you enjoy and focus on this video. It starts as a point, but slowly all the gas coming in, spiral in, accreted, and becoming bigger and bigger and bigger. Right? It's now, if you observe on the upper right-hand side, you see 2 other galaxies, 2 other bright spots. They're actually being absorbed by Milky Way. Small galaxy get bullied by the big Milky Way to become an even bigger Milky Way. So I would say Milky Way is actually a cannibal in its formation. It's not actually that nice. It actually eats all the nearby smaller galaxies, dwarf galaxies, so you don't see it. Okay. So I don't want to play this long because it takes a long time. But as you can see, this is kind of the end products of the galaxy formation. See, there are another galaxies being sucked into the Milky Way and joined to form a bigger galaxy. All right. So this is the Milky Way today. Oops. Is it an error? You guys seeing anything? Might not be showing things.
No,
See
black
black.
color. Whole black screen.
Got it.
Okay, here we
Milky
go.
Way today.
So this is the Milky Way today. Notice that not just the Milky Way itself, but it has got a lot of companions, the babies of the Milky Way. They're being sucked in during its formations. Like 10 of them, more than 10 of the smaller galaxies, we call it satellite galaxies revolving around the Milky Way. Is Milky Way dying? Asked by Tifa. Interesting question. We're gonna find out later. Right? Don't spoiler. We're gonna talk about now the future of Milky Way. Having seen the formations, now I'm interested about the future of our home. Would it be destroyed? Would it get bigger? Or would it just stay like that? The hint is it's not that good. Right? The future of Milky Way is like a bit depressing. So you guys might guess, type in the chat box, what do you think the future of Milky Way will be? I'm gonna reveal the answer. This therapy. All right, let's find out. So before this, I'd like to introduce the Milky Way neighborhood. So not just Milky Way is not alone in the universe. It has some good friends and neighbors in between. A lot of neighbors actually, but the significant ones are the Milky Way, Andromeda Galaxy, and Triangulum Galaxy in the neighborhood. Right, it's quite near to the Milky Way. So I'd like to spend some time on our big brothers, our neighbors. First of all, the Andromeda galaxies. Actually, if you see carefully, let me play the video. The reason why it's called Andromeda Galaxy is because it's near to a constellation called Andromeda. So nothing special about the galaxy, just that it's near the Andromeda constellation. Again, the same thing goes to a triangular galaxy. The galaxy is not triangular at all, but it's near to a constellation called Triangulum constellation. So that's why the name comes in, Triangulum Galaxy. Okay. What do you think in the future? What do you think will happen to three of them? Eat by the other universe, disintegrate as the universe is expanding? No, the answer is they're gonna collide and they're gonna merge into one single big giant galaxy. Now there is a very good artist impressions on the internet. This is the galaxy. This is the sky that we'll see today. Have a nice Milky Way, the milk, and one small thing, Andromeda Galaxy. 2 billion years after, we see something like this. Scientists have calculated that Andromeda and Milky Way, they are moving closer to each other, but it takes a big time. It's like a long time, right? So this is 2 billion years after. 4 billion years after is 3.75 billion years after. It's kind of scary. It's really scary to see that Andromeda gets super big right now. And 4 billion years, the collision happens. And you'll see something like stars and matters, gas scrapping around each other, and the collision just happens after 7 billion years. Now, this collision takes like 3 billion years. After 7 billion years, you see a boring thing. This is what I've shown you in the early example of the different type of galaxy. The elliptical galaxy, the boring thing that none of you voted for. Seems like the future of Milky Way is a boring galaxy. So the result of merging. I want to show you again a wonderful simulations. This is our Milky Way, right? And we have Andromeda at a proximity. It's very near to us, and a triangular galaxy. And look at just how they come closer to each other and merge. They're not gonna merge in a short time. It's gonna take a long time for them to merge and collide multiple times before they finally, as Jeffrey say, reunion. Right? Oh, you may say reunion. Yeah, it's kind of like a reunion. Right. So they merge into one single galaxy, waiting for this triangular galaxy to merge again. Okay. So one natural question you're gonna ask is, actually, how do we know so much, even though we're just on Earth? Now, this I have to thank two of the main things in astronomy. The observations and the simulations really helps a lot, right? Helps a lot in this. That we are able to kind of assume things without having to see it during using simulations. In using observation, we can actually prove that. All right. So, this is a fun fact. I want to talk about this. Sometimes if you see astronomy news, you'll see a lot of cute acronyms. I would say, like, working in astronomy, I see a lot of bad acronyms, and I want to just show a few examples. Bistro. Okay, Bistro is a local food store. And it's named as one of the astronomy survey and observation. Alfalfa, right? Alfalfa, it's a supplement. If I check online, it's a supplement. It's a survey in the astronomy field. Malatang. Some of you might know what it is. It's a kind of Chinese food. Somehow it turns itself into a survey in astronomy. Bicep. If you do gym, you love bicep, but apparently astronomers, they like bicep too. So it's kind of funny to see all the cute acronyms happens in astronomy. And if you notice carefully, they actually kind of try hard to do especially the Malatang case. If you see the acronym doesn't really make sense in terms of the full explanation, right? This is one thing I want to point out. All right. Summary. Okay, here's my summary. First of all, astronomy, they like duck tests. If it looks like a duck, seems like a duck, and quacks like a duck, probably it's a duck. But we don't really see the duck, right? We just guess it might be a duck. So we do this all the time. They do this all the time. It all starts with gas gathering at a point, the formation, right? Milky Way is a cannibal. He likes to eat all the smaller galaxies to make it bigger. The future of Milky Way is not so good. A lot of collision happens and fears. And I would like to appreciate simulations and observations that relies on expensive telescope and expensive computing power to make this all happen. I want to end my presentation with a nice photo taken in Kedah by, again, one of the other astrophotographer in Malaysia, Muhammad Safwan. Thank you, Inje Safwan. Kind of emotional photo. Right, thank you so much. I want to answer questions right now. All right, let me see the time. I've got some time. Yellow. All right. So let's answer the first question. Is there large explosion when two galaxies merge? There's no explosion. In fact, the galaxy is so huge that some part of galaxy might not be affected at all. Right? Because the merging, the collision happens kind of in the middle of the galaxy. So probably their theories say that the place of our solar system, the Earth, might not be affected because we are not at the middle. Right? We are quite at the outside area. Okay, so I hope that answers your questions. Oh, great. I have 1 minute. Anyone want to do voice questions? Feel free to voice out.
Hi, Minkang. I'd like to ask you a question.
Yes, go ahead.
So when two galaxies collide, right? And you have said earlier that something will happen towards the center of the galaxy of these two galaxies when they're merging and colliding. So would you mind explaining how it really works exactly?
Oh, so if you see these simulations, the two galaxies are actually colliding heads on, right? Heads on instead of so two of the cores, the center of galaxy actually two of the core are exactly colliding with each other. They are not colliding at the side, but they are at the center. because the center is the massive, right? If you have the massive at the center, then quite naturally the massive will come into together, just like the gravity, just like how you draw onto the Earth's surface. Like, I hope that answers the question. It's not really that detailed, but I don't have much time.
Okay,
So
okay. Thank you so much.
Basically, it's because of the gravitational force between two galaxies so huge. So they always collide at the center.
I heard the center of every galaxy is a supermassive black hole. Is that true?
Most of them, right? Most of them. That's why it's so massive at the center. Right.
That's all from me.
I can afford one more question.
That is from Xing. If collision happens, what will happen to Earth besides the night sky?
Okay, to be honest, you wouldn't even see night sky at all. Because by the time the two galaxies collide, the solar system will have died out. Because the sun dies like way before, the sun exhausted its fuel, died off way before the collision happens. So the Earth will die off because no sun, right? So all of us will die, even our descendants. Unless we have somehow to make a new star using future supermassive technology. But if the sun dies off with the current technology, the solar system will not survive way before. The solar system will die way before these two galaxies collide. But if our Earth still survive, right? If there are still people out there, I don't think we'll have anything happens to us at all, because we are not at the center. We are like spectators, We're just looking at the collisions happening. I hope that answers your questions.
Yeah.
Okay, thank you so much. I see Jeffrey is really red right now. Thank you. So I hope you guys enjoyed the journey of our home, Milky Way, and I would like to pass the stage back to the